Voyager 1's stunning comeback. The 47-year-old probe that phoned home from interstellar space. It began as a simple command. On October 16, 2024, NASA engineers sent instructions to the Voyager 1 space probe, now drifting nearly 25 billion kilometers from Earth, to turn on one of its onboard heaters. It was a routine maneuver, a basic check to maintain functionality of the nearly 50-year-old spacecraft. But what happened next shocked everyone. Instead of a routine response, Voyager 1 went silent. The Deep Space Network, the massive array of Earth-based antennas used to communicate with distant spacecraft, could no longer detect its signal. For a moment, it seemed as though the most distant outpost of humanity had vanished into the void. But this was not the end of Voyager 1's journey. In an incredible twist of interstellar resilience and brilliant engineering, the ancient probe managed to re-establish contact using a backup transmitter that hadn't been used since 1981, a system forgotten by most but vital to saving the mission. This is the extraordinary story of how Voyager 1, with technology dating back to the 1970s, overcame one of its greatest challenges yet, and how it's still going strong almost half a century after launch. Rocket a mission beyond time. The legacy of Voyager 1. Voyager 1 was launched on September 5, 1977, as part of NASA's ambitious mission to explore the outer planets. Along with its twin Voyager 2, it was designed to take advantage of a rare planetary alignment to perform a grand tour of the solar system, visiting Jupiter and Saturn with the possibility of going further. The initial mission duration? Just 5 years. Fast forward to today. Voyager 1 is nearly 47 years into its journey and still operational. It has long since completed its planetary tour and is now flying through interstellar space, farther than any other human-made object in history. At a distance of roughly 25 billion kilometers, more than 166 astronomical units, from Earth, Voyager 1 has entered the realm where the solar wind fades and the interstellar medium begins. It continues to send back priceless scientific data from this mysterious frontier, the very edge of the sun's influence. But keeping in touch with such a distant traveler is no easy task. IceCube, a routine command, turns into a crisis. On October 16, 2024, NASA engineers instructed Voyager 1 to activate a heater on one of its instruments. At first, nothing seemed amiss. But after nearly 2 days, a time frame necessary due to the 23-hour communication delay each way, NASA realized that something had gone wrong. The probe's signal was gone. The cause? Voyager 1's onboard fault protection system, a form of automatic safety mechanism, had been triggered. These systems are designed to protect the probe from critical failures, particularly when power is overloaded or an unexpected condition occurs. When such a system activates, it begins shutting down non-essential systems to conserve energy. Ironically, despite having enough power to activate the heater, the fault protection system interpreted the command as a potential overload and reacted by shutting down or altering the transmission system. What complicated matters further was that Voyager 1 communicates via its X-band transmitter, which operates in the 8 to 12 GHz range. It's designed for relatively high-speed interstellar communication. But when fault protection kicked in, it reduced the data rate and altered the frequency signature of the signal, making it harder for NASA's Deep Space Network to detect. Magnifying glass tilted right the long search for a lost signal. NASA engineers began a painstaking effort to search for the altered signal, scanning possible frequency ranges where the weakened X-band signal might have shifted. Finally, on October 18th, the signal was rediscovered. It was a huge relief, but the problem wasn't over. The next day, communication broke down again. NASA's engineers suspected that the fault protection system had gone further, this time disabling the X-band transmitter entirely and switching Voyager 1 to its backup S-band transmitter, a system that had not been used since 1981. Radio, a 40-year-old backup, saves the day. The S-band transmitter, operating at a lower frequency than the X-band, consumes less power, but also transmits data more slowly and with less fidelity. Originally designed only as a backup system, it was known to be less robust and hadn't been tested for decades. There was no guarantee it would still work. Still, NASA took the risk. On October 22nd, they sent a command to the spacecraft to test the S-band transmitter. 2 days later, on October 24th, they received a response. Voyager 1 had phoned home, using a system that had sat dormant for more than 4 decades. It was a testament not only to the probe's durability, but to the brilliance and foresight of the engineers who designed it back in the 1970s. Counterclockwise zeros button returned to normalcy. NASA carefully analyzed the situation before attempting to restore the X-band system. Given the unpredictable behavior of the fault protection system, they feared that rushing a reset could cause a permanent shutdown. Instead, they waited. After detailed troubleshooting, engineers issued a series of corrective commands. Finally, on November 26, 2024, NASA confirmed that Voyager 1's X-band transmitter was fully operational once again, and that the spacecraft had resumed normal communication. The ancient probe had survived yet another crisis, and emerged more resilient than ever. The challenge of aging technology. The fact that Voyager 1 and Voyager 2 are still operating is nothing short of extraordinary. These spacecraft were built using 1970s-era technology. Their onboard computers have fewer instructions than a modern washing machine. They store data on magnetic tape. Their communication system transmits data at a rate 38,000 times slower than a 4G smartphone. And their power systems, radioisotope thermoelectric generators, RTGs, have been losing capacity every year. Originally delivering about 470 watts of electrical power, the RTGs now produce less than half that amount. With a loss of approximately 4 watts per year, NASA has had to implement strict power-saving protocols, turning off non-essential systems and even some scientific instruments. Battery instruments going dark. To preserve power, NASA has gradually been shutting down instruments. In 2023, backup systems were deactivated. In 2024, the cosmic ray subsystem on Voyager 1 and the low-energy particle detector on Voyager 2 were switched off. By 2026, more instruments, including the low-energy charged particle sensor on Voyager 1, are expected to go offline. As of now, Voyager 1 still operates 3 scientific instruments: the magnetometer, the plasma wave subsystem, the low-energy charged particle sensor, scheduled for shutdown in 2026. Voyager 2 retains similar capabilities, but is also losing power year by year. Despite these limitations, every bit of data they send back is precious. Brain lessons in engineering, patience, and legacy. How is it even possible that 1970s-era spacecraft are still flying and functioning in the harshest environment imaginable? The answer lies in robust engineering, foresight, and a bit of cosmic luck. The Voyagers were overbuilt, meticulously tested, and packed with redundancy, such as that decades-old S-band transmitter that just saved the mission. These probes are more than machines. They are interstellar ambassadors, carrying the famous golden record, a phonograph disc containing images, sounds, music, and greetings from Earth, just in case they are ever found by another civilization. Compass, the final chapter approaches. NASA predicts that Voyager 1 and Voyager 2 can continue operating into the early to mid-2030s. After that, there will not be enough power to keep even their communication systems alive. But even when the signal fades for good, the Voyagers will continue on forever, drifting through the galaxy as silent messengers of Earth. They've taught us more than we could have imagined, not only about the outer solar system, but also about the resilience of human ingenuity. And they remind us that even from 25 billion kilometers away, with outdated tools and fading power, we can still find a way to phone home. Man astronaut, want to stay updated? If you're fascinated by stories like these, of ancient spacecraft defying the odds, of humanity's deep space explorers, of the boundless curiosity that drives us, join our community. Hit that subscribe button or follow along as we continue to bring you the latest from the final frontier. We'll see you again on the edge of the universe.